Hello, everyone. Thanks for joining us today. Welcome to this Telit webinar, What's Next for 5G? What you need to know about 3GPP Release 17. I'm Amanda Flink, the head of global events here at Telit, and I will be moderating our discussion today. Before we get going, we would like to poll our audience real quick to understand what best describes your interest in 5G. You could take a quick second to fill out the poll question, which you'll see on your screen now. Now let's get to know our speakers real quick. To explain this topic today, I'm pleased to be joined by two Telit speakers. First, we have Jeff Clemo, VP Strategic and Channel Sales. Hi, Jeff. Thanks for joining us today.
Hey, Amanda. Looking forward to it.
And second, we have Safi Khan, Regional Product Marketing Director, also here at Telit. Hi, Safi.
Hi, Amanda. Hello, everyone. Very happy to be here today.
Just before I hand it over to Safi to start our presentation, I do have a few quick reminders. I would like to encourage our audience to interact by posting questions. We will have time to answer some of those throughout our presentation today. Simply submit a question by posting in the box to the right of the slides. Also, please be sure to check out the resources section in the upper right-hand corner of your screen for some additional information on our topic. Finally, we will send out the replay link to all attendees at the conclusion of the webinar. And with that, Safi, I will let you kick us off.
Thank you, Amanda, and hello, everyone. So today we are going to be talking about 5G. So I think it's only appropriate that we start with basically the overall outlook from a market perspective on where 5G is headed. So as you may be aware, of course, that there has been many evolutions of mobile standards. For example, we are in the 4G era right now, which is also called LTE, the long-term evolution. And the emergence of 5G, as shown here, is basically a tipping point in the industry. And we are headed towards a very big economic opportunity for all the businesses across the spectrum. And according to this market research by IHS, now called Omdia, they expect that by 2035, this is going to be a $13 trillion global economy or global sales activity. And basically, there's a fundamental shift where everything that you can imagine is basically going to get more and more connected, more and more smart, and massive amounts of data will be generated by these devices and sensors and used in many, many different verticals, which we will talk about today in our webinar. And so it's a very exciting time to be in this industry and also in this evolution of 5G. And so 5G is just, one name, but really the devil is in the details, and that's what we are here today to talk about so that we can break it down for you in terms of releases, release 16, 17, and beyond, and what does it all mean. So let's take a deeper look at what really goes on behind the scenes, which then becomes 4G and 5G. Okay. So there is a standards body called 3GPP, which stands for Third Generation Partnership Project. So this is the name for the global standard setting body where all the companies give inputs to the new standard based on all the engineering research that their company has done and all the methods of improvement and optimization and innovation that come with it. And so then the body consists of voting members, and they all discuss the work items and study items presented. And there's a very structured, methodical way of coming up with a final agreed upon standard specification, which is then called a release. So as shown here, in 21 and 22, the work that 3GPP was doing is mainly focused on completing release 17 of 5G. Now, this is actually the third release of 5G, and some of you may be surprised to know that the first 5G release was release 15. and the second release is 16, and now 17 is what we will talk about today mostly. However, we will touch upon aspects of release 15 and 16 because this is a continued, ongoing continuum where some items are completed and they make it into the standard. Some that are incomplete or delayed, they make it into the next standard. So as release 17 is expected to be completed sometime later this year, that is only the beginning of the work, where only the specification on paper is completed. And afterwards, there's a whole set of activities that get kicked off once a 3GPP standard is completed. But in parallel, as you can see, there is an overlap where different groups within 3GPP work on different releases. So as 17 is nearing the completion, it took about 2 years, let's say, to develop that. Last year, they already started the initial work for the package of approved items for example, release 18. So this is basically what the whole process in the industry looks like. And sometimes, multiple of these releases are grouped together as a G or a generation. So 5G, for example, is released from 15 up to 18 so far. So these releases are loosely called 5G. And release 18 onwards has been actually called 5G Advanced, because up to release 17 are features that are basically required to build the foundation of 5G. And then from 18 onwards, they will bring in even more advanced features that build upon the foundation. All right, so from that point of view, let's just jump right into a slide that essentially captures in one place all of the major comprehensive features of release 17. So we are, of course, assuming here that you are familiar with release 15 and 16. But if you are not, then nothing to worry about. You can always refer to all of the webinars on our Telit website, telit.com. And we have done previous webinars where you can learn about release 15 and 16. So I don't have to go through this whole list to read it out to you, but basically these are those work items and study items which are proposed and make it into the release 17. And for example, today we will cover some of these things, not all of them because we don't have enough time. NTN, for example, which is a non-terrestrial network, is a new technology where 5G will operate over a satellite link. We will cover that. We will also cover basically the reduced capability UE or user equipment, where basically you have a evolution path for the LTE devices to become native 5G devices. And then there are other aspects like enhancing the release 16 features or adding capabilities for more higher performance AR and VR, extended reality feature set to make it low power, and then of course lower latency, which was introduced in release 16, and so on. 5G touches a lot of industry verticals, especially, for example, there's a lot of work going on to help with autonomous cars or autonomous driving, which is called V2X, so vehicle to infrastructure or vehicle to vehicle or vehicle to network. So there's many enhancements for V2X services. Of course, 5G is a new core network architecture, and it's much more efficient. So there is also more enhancements for edge computing in the 5G core, where more and more of these devices can have lower latency because essentially the cloud comes with the 5G core towards the edge and closer to the end devices that are generating the data and getting efficiencies and business optimizations using connected data analytics, and so on. So without going into each one of these, I just touched on some of the high-level features, and we will dive into some of these in the next few minutes. Okay, so what are some of the focus areas of the release that the standard really worked on and spent all of its energy on? So we can loosely divide this into 3 buckets as shown here. The first bucket is new concepts, like, for example, the satellite shown there, the XR, the extended reality, the wearable RedCap devices, and then other enhancements. The second bucket is enhancing already released features of Release 16, which didn't have a time in the previous release to really refine them into much more advanced, more mature, fully developed features. So these will include some of the vehicle-to-X features, as well as the ones shown here about broadcast, so doing an EMBMS type of multi-broadcast system over cellular 5G network. And then the final third bucket is perfecting Release 15. So they even go as far back as Release 15 to cover all of the basic fundamentals, like I was talking about, the foundational work. And this includes enhanced mobile broadband, the massive machine type communications, integrated access and backhaul, etc. So we will cover that as well. So these are the focus areas for Release 17. So moving right along, if you now focus a little bit on each one of those in a little more detail, you get to see what is really under the hood. And this is why I emphasize that 5G is a moving continuum where you really have to know what particular features are productized in a chipset, which ones are really the firmware and the software have been tested and interoperability tested with the infrastructure, because from a high level, there could be many features of 5G that look very exciting, look very cool, but what you really have to know is if they are fully implemented and the carriers have actually deployed them in the actual network. So some of these, for example, starting from the top left, let's take extended reality as an example, right? So this is a new concept where in 5G, they're trying to evaluate and adopt 5G for XR. Now, what can you do? So XR means putting on a headset, and you've all heard about the metaverse. It's a big thing now where companies are pushing the boundaries to basically have an alternate digital world where you can have mixed experiences with real life mixed with augmented life. And so you need distributed architecture, and the cloud has to come to the edge, simply because when you're wearing a headset, your eyes are very sensitive to the latency that you see or a lag that you see when your head moves around. And if that latency is noticeable, even slightly, studies have shown that you start getting headaches. And obviously, these companies want you to feel comfortable wearing these glasses as a natural extension where these headaches are not there and you're not feeling dizzy. So you need very low latency, and for that you need to bring the cloud closer to the edge, and that's what 5G Release 17 will do. And of course, more device capabilities like higher performance, lower power consumption, so you can run on batteries. You don't have to have a cable tethered to a big cable where you plug it into the wall. So battery powered, but high performance is the XR. So that's needed. Then moving over to the right, you have millimeter wave frequencies in the higher spectrum. So they previously had defined all the way up to 32 gigahertz, but in Release 17, they also want to operate in the 50 to 70 gigahertz range. And of course, now this will give expanded spectrum for the millimeter wave operation. higher speeds and capacity for the network. And also, it could be used for backhaul type of services where you can have the cell towers talking to each other at this high frequency if they're line of sight, and then use the other spectrum, which is used for the front haul, meaning between the devices. So that's a new feature. Then on the lower left, we have a new concept called non-terrestrial network, NTN. So this is basically an effort to take the satellite infrastructure, which is already there, and adding a 5G native radio front end to it and making all of the low power, low data rate sensors to be satellite capable, but running a cellular protocol. Now, you may ask, why would you do that? The answer is that there are remote areas where 5G or 4G is not deployed. And so those are coverage holes where if you, for example, have a tracking device on a truck and it's traveling outside of an urban area, and when it goes into a remote area where there is no coverage, you don't get the tracking updates. So with this NTN feature, the device will be able to switch from the cellular coverage to the satellite coverage, because obviously when a truck is driving in the open air, it has access to the satellites. It can see them. So rather than requiring a complete satellite modem, by having this NTN feature in 5G, the same 5G modem will be able to receive or send transmissions through the satellite link. So this is a very useful feature for example, agriculture, shipping, and trucking and transportation. So basically connect IoT outside of the cellular coverage area. And then last but not least, another exciting area is the one on the lower right, which is 5G multicast broadcast. Now, this is nothing new because in 4G, there was also an eNBMS, which was called Enhanced Mobile Broadcast Mobile System. And this is essentially a way to leverage the capacity of a cellular network to basically send the same content to multiple devices. So you can imagine you have the TV broadcasting where the tower is broadcasting and all the television sets are receiving it. So the same concept, but for mobile phones. So instead of each phone having to listen to its unique frequency, the phones are actually listening to a single frequency or a set of parameters they know how to tune. And this channel, or I would say a single channel, where the broadcaster is basically sending, for example, a sports feed in a stadium. So all the cell phones could be receiving that same feed and receiving it at a much lower data capacity because the cell tower doesn't have to send individual packets to every phone. It just broadcasts them for everyone. Now, in MBMS, there's also other use cases which are very important, which are listed like, for example, public safety. First responders can have public messages about disasters or fire. What is the status? Firmware over the air, so all the phones could get a firmware update in a broadcast way by reducing capacity in the network and using it more optimized way. PTT stands for push to talk, so this could be like a walkie-talkie feature, and then of course live TV. So these are some of the features that we thought of highlighting for you in this particular webinar. But of course, like I said in my previous slide, the list is very long. Now, moving along, there is one other aspect of Release 17 which is very important to touch upon, and we've received a lot of queries from our customers about this as well. And that is something to do with RedCap. Now, this name may be familiar to some of you and may not be to others, but essentially RedCap is an acronym for something called reduced capability. And reduced capability RedCap is basically devices that will eventually replace the Cat 1 and Cat 4 LTE devices. So all of the Cat 1 and Cat 4 LTE devices are not compatible with 5G native radio, the new radio. they are the LTE waveform. So they will exist for a long time. They're not going away. But obviously, the operators and carriers want to leverage their 5G spectrum to have a transition path for the very long term. And so in 5G, 3GPP, they have now defined a device called the RedCap, because the first devices that came out for 5G were very, very high performance and were used for something called EMBB, which is enhanced mobile broadband. So those are like, for example, gigabit speed modems that can download massive amounts of data. But you don't always need them. What about, for example, few hundred megabits of data? If you want only a smaller subset that wasn't in the initial release 15 or 16, so now release 17 is saying that RedCap will be the definition of a low complexity, reduced receive and transmit, smaller bandwidth device, and it will have a half duplex operation, for example, so it will only be able to either transmit or receive at any given time, and it is to reduce the cost. And then, of course, the target market for this is initially the wearable devices and IoT sensors and other use cases. So it is not a enhanced mobile broadband device. So RedCap is not going to replace the higher end 5G modem. It's a new class of modems that will be introduced in release 17. And some people used to call this NR Lite. And that's another question or a misnomer where people may think that NR Lite is different than RedCap, but basically RedCap is the new name for NR Lite. I hope that is clear. Moving along then, so now we've covered, one of those buckets that I had identified earlier. Now there's another bucket that I said, which is to enhance the release 16 features. So this is a little bit more involved, and you have to know the background of all of the release 16 features that were introduced, where release 17 will just basically further enhance them to make them more mature. And so this IAB, starting from the top left, means that your backhaul and the access is integrated into the same tower. So a very simple way to explain this is that in the picture you see the two towers. Now, how do the two towers talk to each other? The traditional way is to dig the fiber cable or Ethernet and have them connect with a high-speed wired link. Now, IAB is a feature where they will use, for example, the high millimeter wave spectrum to have the towers talk to each other on a different frequency, and that doesn't interfere with how the towers talk to the cell phones or the 5G devices. So this is what we mean by integrated access and backhaul. And so this infrastructure is smart enough and more capable that when you want to expand the coverage, you can just put up a new tower, but you don't need to run fiber or cable to that new tower. You can just easily power it up, maybe with solar or batteries or with real wall power, but that's all you need. You don't need a high-speed fiber link to be dug up. And the tower will talk to the other tower wirelessly. So that's a very useful feature. So that's coming in release 17. Similarly, there are other features, and I don't have to go through each one of them in too much detail because we don't have that much time, but I'll quickly cover them. For example, on the lower left is something called side link, and this is basically extra signaling for the vehicle-to-vehicle communications for autonomous driving or emergency services. So again, more optimized side link for autonomous driving. Then in the top right, we have more precise positioning. So you have centimeter level accuracy using cellular. So you can imagine in a downtown area of a metropolis where you have tall buildings, and if you're walking, you may not see a satellite because it's not in your view because the buildings are blocking it. However, with 5G release 17, you will get cellular-based, very precise positioning, so the modem can switch from GPS to cellular and give you the same level of positioning accuracy. So that's another useful use case coming. Then the lower two on the bottom, it says small data transmit. So again, this is further enhancement to have a direct connection without the full signaling or the call setup. So this will reduce latency and save power. Again, this is useful for that massive IoT, which is one of the other pillars of 5G. And of course, they're also realizing that a lot of people just use messaging apps like WhatsApp or Twitter or Facebook, and they're only using very small amounts of data to check status or reply to a message. And so why bring up this overhead signaling just to set up a connection where you send or receive a little bit of data? So you have this small data transmit as a separate mode, which is more efficient. And then last but not least, on the lower right is the URLLC on unlicensed. So this is URLLC is a Release 16 feature. It stands for Ultra Reliable Low Latency Communications. This is very useful for machine-to-machine operation, for M2M, in factory automation, manufacturing, medical, and AR and VR. So anything where you can have a network that has a 1 millisecond latency, for example, is very, very useful to have many tasks automated to let the machines handle, for example, emergency situations or things where reaction time has to be very fast. So in Release 16, this feature was introduced on licensed spectrum, and in Release 17, they're also trying to make it run on unlicensed spectrum. So these are some of the Release 16 features that we wanted to touch upon, which are now being perfected in Release 17. And further, going back to the last bucket of my initial slide, which is to perfect some of the Release 15 features. So obviously, Release 15 was the first 5G release. It had some really cool innovations, but some of them were not fully matured or developed. So a list over here is a list of the work items and study items that are requested by 3GPP to be looked upon in Release 17. So again, better MIMO or more improved MIMO, multi-radio dual connectivity again. These are advanced modem features that make the efficiency more higher performance or lower power. Dynamic spectrum sharing to be improved for better cross-carrier scheduling, for example, and then coverage extension. So, the 5G bands are higher in frequency, so they have more challenge traveling longer distances. So looking at ways to enhance that coverage through other means, and then multi-SIM and RAN slicing and so on. So all sorts of new features, basically new enhancements to the original Release 15 features. So 17 is a package full of very rich number of features. Some of them are very new, some of them are enhancements to Release 16, and finally some are enhancements to Release 15. So I hope that this gives you a good idea of what Release 17 of 5G is going to bring. And I will end with this slide as my last slide before I hand it over to Jeff. So what's out there beyond Release 17? So basically, I had mentioned this word 5G Advanced earlier. So as you can see, that 5G Advanced is the name that the industry has given to the 5G Release 18 and onwards. And what will happen is that they will introduce some very, very innovative and novel concepts to essentially make the network even better. So starting from the one on the left, full duplex operation. So essentially, this is a way to have very, very low latency full duplex operation where both machines or both devices can talk to each other simultaneously and with very low latency. Then moving on, the biggest feature will be to introduce artificial intelligence and machine learning into the 5G radio or the network, and basically using techniques that have been learned using the AI and ML framework to dynamically manage the connections based on how much load there is in the radio network, how many devices are actively requesting service, where are they located and how much energy or power are they receiving. Are they in a good signal condition or bad signal condition? So with AI, you can train the model to know what was the better response when such a situation happened. And once those models are fully trained, it will be much more efficient to let the AI and ML processing inside the core network to automatically decide for the user what is the best radio resource to be served, what modulation rate, what power level, how many resource blocks, all of the scheduling that goes on in for example, today's architecture is programmatically, predetermined that if this happens, do this, and if that happens, do that. So with using AI and ML, we're taking a leap, a big leap forward in terms of making the decision-making process very, very accurate and more automated and more optimized. So this is to harness the power of AI and ML, and that you will see in 5G Advanced or Release 18 and onwards. And then last but not least, lower energy consumption is more of a environmental initiative where, since there are so many cell towers and so many small cells, they all consume power. And so to reduce basically the power consumption footprint and going green, the Release 18 will look at how to bring the overall power of the system down so that, data centers, power, and the network centers all consume less power, which is better for the environment. So I think with that, I will wrap up my session on the key features of Release 17. I hope you enjoyed that. And with that, I'll hand it over to Jeff to take it to the next step.
Thank you, Safi.
Jeff,
Go ahead, Amanda.
Yeah, before you get started, we've actually gotten a lot of questions, so I thought maybe we could pause and take a couple of these before we sort of move to the next section here, if that's okay.
Sounds good.
Sure.
And I've gotten a couple of questions that kind of go hand in hand, so I'll combine them so you can kind of answer them together. But first question here is, which chipset is supporting Release 17 now? When do you expect Release 17-based devices to be in the market?
That's a very good question, actually, since we're talking about Release 17. So let me clarify that today there is no chipset that supports Release 17, simply because Release 17 is still being developed, and the completion is expected to be sometime in the middle of 2022. And after that, there will be some time before the chipsets are available. So the short answer is no. And the answer to the second question would be that, like I said, sometime in 2022, Release 17 will be done. I expect chipsets around 2024 timeframe, and then commercial network or commercial devices with Release 17 to be available sometime around 2025 or after.
Thanks, Safi. Another question I've got here, which you kind of covered, so good one to go through right now. I thought EMBB, Massive IoT, and URLLC were already defined in 5G, so why are they still being worked on?
Okay, well, that's another good question. So let me just say that when Release 15 was developed by 3GPP, the industry identified three main pillars of 5G, which is what the question is being addressed about. So let me, for the benefit of the audience, explain them quickly. So EMBB is the first pillar of 5G, which is enhanced mobile broadband, meaning that it's a 10x improvement over 4G, and you have multi-gigabit speed that you can receive in the downlink wirelessly, and that is using the enhanced mobile broadband of 5G. The second pillar was a massive machine type communications, meaning connecting millions or billions of devices together. So having the scale to have very low power and low data rate devices all the way up to very high performance devices, all being served by a single core network, which is agile and scalable and doesn't waste resources and can handle this dynamic range of devices. And the idea was to connect millions and billions of these sensors and machines and devices together on the 5G network. And then the last pillar was URLLC, which is ultra reliable low latency communications, and that is for sub 1 millisecond end-to-end latency between two nodes that are talking to each other. And that helps open up new cases like augmented reality, manufacturing, machine-to-machine, autonomous driving, AR and VR, robotic surgery. You can keep going on and on. So these three pillars were defined in the 5G, yes, but the actual implementation is coming in these releases. So again, like I have said in the very beginning, 5G means a lot of things to a lot of people, but really the devil is in the details. And so Release 15 was all about eMBB. Release 16 introduced the URLLC, and now Release 17 will perfect the massive machine type communication. So by Release 17, we expect all three of them to be fully matured and developed.
Great. Thanks, Safi. I think that covers it for now. We've got other questions that I think we can get to at the end here. So, Jeff, sorry for barging in, and I'll hand it over to you.
Not a problem. Got it. Can you guys hear me okay?
Loud and clear.
Super. Okay, to kind of pick up on where Safi's been highlighting the 5G Release 17 and really talking about the roadmap and what the ultimate end state dream for the 5G technology will look like. I'm going to kind of bring us back to where we're at today and how we're going to get to that point from where we're at. So this slide really just talks about how 5G releases get commercialized for IoT. Spend a lot of time talking to customers about their plans. And I really want to emphasize here that, you know, when you listen to the storyline like Safi was putting together and you hear something that's really exciting, to take time to learn where that might be from a technology standpoint, available in the commercial market, and link it back to your use case or your design plan, because we've had a lot of initial 5G interest this last 18 months, and a lot of customers found that they thought they knew what was available today in the current chipsets that are Release 15, and were disappointed when they didn't see some of the 16 and 17 release features yet. So really understanding where they'll sit in the timing. So as Safi alluded to, you know, the 3GPP standard is frozen usually about mid-year. So in this case, 17, sometime mid-2022. Then the chipset guys like Qualcomm have to go out and do their design, and that can take, you know, upwards of a year and a half, depending on, and it's getting more and more complex with 5G. That's why I'm saying depending on the technology. Whereas, you know, CAD-M was a little more simplistic. And then you have companies like Telit who will take that chipset and encompass it with all our firmware and feature functionality and wrap it up into a commercial product. That timeline usually takes 2 years, and that does not include the timeline then for the end customer to do their development and design, whether it be the software integration of all these new features into their back-end systems, to their end devices happen to be redesigned because of the new form factors and the antenna requirements. So there's a lot of variables that go into it, and it takes a long time. That's why I like to call 5G, you know, a long road ahead of us. And as the feature functionality that's pertinent to your use case comes into play, understanding when commercial products will be available and what the requirements are for development is really key. So, you know, we'll be glad to help you with all those questions down the road as we continue down the path to ultimately Release 18. So from a Telit perspective, we've had our two products in the market now for quite some time that are based on Release 15. They're both M.2 data cards, the FM980, which is sub-6 only, and the FM980M, which is millimeter wave. And what I want to talk about now is really a lot of where the market is today. We have seen adoption by the router high-end gateway niche type of segments that really need the increased uplink that you can see with 5G, as well as the downlink. And this was an area where that part of the market has really adopted new designs and has been moving forward and is currently releasing mass production products into the marketplace. And the ability to have backward compatibility to 4G and 3G, depending on where you are in the world, was a key part of that. And I think that goes to the whole planning process I'm talking about. As you're looking at your 4G strategy, your migration to 5G, and what that will either change in your end product from a design perspective or what it'll enable. Those are all things that you'll want to take into consideration. Moving on to the next slide. Basically, with the FM980M and 980 key features, you're seeing that the data cards are global. They cover most of your major carriers around the world that have deployed 5G. You have all the features that are built into the Release 15, as well as the GPS, GNSS capabilities. And as Sophie alluded to, that positioning capability will continue to improve as we go down through the releases. The question we get asked a lot of times is, what bands are covered, what carriers are covered, and it has gotten a lot more complicated with 5Gs with all the carrier aggregation combinations and each of the carriers having different assets. So the complexity of the band combinations has grown exponentially, and it is something you'll want to factor into your design efforts as well. But obviously, knowing what carriers you're going to work with and whether you're going to be a regional or global type of deployment is a key to the design, but it's not necessarily key in deciding the actual module because these are global SKUs. So, the other thing that I think is important is looking at how 5G has been marketed to enhance verticals that already exist in the marketplace for cellular, and then enhancing some of those, and then also adding new ones. So we've seen, for instance, in the robotics and the remote controlled type of environment that really requires a lot of data going both ways, 5G is got good potential with the sub-6 capabilities. Smart agriculture, again, 5G starts to bring in the ability to do aggregation across a large farm or a large environment. A lot of what you see in some of these verticals is still to see the full potential as we go through the next releases, especially with Release 17, when you're going to get into the low end of 5G, because right now everything's really focused on the high throughput, low latency side. But whether it be a smart factory or car to car, B2B type of communications, or it's aggregation of much broader number of sensors, whether in smart buildings or smart agriculture, all this stuff is there today in various forms, and all 5G is going to do is continue to bring more capabilities to those verticals. And so we'll start to see either faster pace on some of the solutions that are out there today by moving to 5G, and in other cases, you'll see whole new capabilities. So, like I said, and Sophie really illustrated well, is we're going through these generational life cycles, and there is some significant overlaps, and we hear all the time, especially folks that have already been through the 2G and the 3G and the 4G efforts, with the 3G sunset coming up here in a day or two, if not today, I think it was somewhere in the next day or two for AT&T, and then you've got 2G networks that are still out there and probably will be in certain parts of the world for quite some time yet. But you can just see how these curves kind of overlap. And it goes back to what I started with in making sure that you're matching the technology for what your use case is, and you're matching the timelines of development with these kind of curves and timelines that you see. So if you have a 4G design that's working great and you don't have anything in the 5G feature set that's really going to make or break your product, then you're probably got many, many years to go before you have to start worrying about migrating to 5G. But again, understanding those transition paths, what it means for your design, is always going to be important. Key benefits and why 5G will revolutionize. I think we've talked about this kind of indirectly and directly throughout the presentation, but more spectrum and more efficient use of that spectrum. So we've gone from the 600, 800, 1900 bands of the 2G, 3G days to everything up and down the bar of bandwidth, and you're seeing today mostly sub-6 capabilities being taken advantage of because of the similarity to the LTE designs. But there are obviously use cases where millimeter wave really starts to take hold, and we'll see more and more of that, especially as the carriers start using it themselves in their own network infrastructure. Increased layered coverage, higher throughput, especially on the uplink. I get asked a lot of times, why would I take like a high-CAD LTE product versus 5G? And one of the big differentiators is the uplink. 5G has obviously got a much bigger uplink than LTE. So it kind of depends on whether you're uplink or downlink centric. Lower latency and higher reliability that'll be coming in release 16 are really key. And again, we've talked about, right, new use cases for something that you are doing today, maybe with another RF technology, but this will enable you to do more mobility or more portability or some combination thereof. But obviously, being able to drop in a network infrastructure easily, and we're also seeing more and more interest in private networks that are not even tied to the MNO networks, and that's all feasible within the 5G realm. So some of the early use cases are pretty obvious. You've got the higher bandwidth video camera equipment. We've seen some pilots with people that are working on 360 video for sporting activities. Laptops and tablets that require really high-end throughput, especially your industrial grade type of devices that may be used out in the field. Your enterprise router SD-WAN space is probably the first in leading the way through new products that are coming out with 5G. CPE business is going to continue to grow. Factory 4.0 in looking at ways to make their factory floors more flexible are looking at 5G. And so there's just all kinds of examples that we're seeing from a use case perspective. And then some of the next wave are what we've already talked about in my earlier slide with private 5G, whether it be over a factory floor or whether it be in the outdoors around a agricultural or a grouping of greenhouses to large scale campuses and things like that. Telehealth will obviously play a major role in 5G as you see more and more equipment OEMs that are working with outpatient scenarios and trying to enable doctors to get real-time information. And in some cases, that equipment's going to be taking larger data dumps than just, your weight off of a scale or your blood pressure from a blood pressure monitor. Just envision, doctors being able to see real live video feed in an ambulance as they're treating a patient from an emergency. So there's all kinds of things that down the road you'll see 5G enabling that are not there today. And with that, I think we're pretty much at the end of the presentation, Amanda. We've covered, the release 17, what's coming, where we're at today with release 15. 16 is coming here in the beginning of 2023 because we'll start seeing commercial module availability around Q1 of 2023. Sampling is already starting for folks that are looking at doing release 16 development. and then we'll just keep on marching down to the release 17 as Safi laid out those timelines. But it's here to stay. It's going to continue to grow and expand, and we're always available to help folks with questions and trying to understand what's becoming a very, very complex business model. That's it for me, Amanda.
Thanks, Jeff. Before we get to a few more questions here, I am going to drop just one last poll on your screen. If you'd like to have one of our experts contact you directly, please go ahead and respond here on the poll, and we will have someone reach out. We do have time for a few questions. I know we're coming up on the hour here, so we will do our best to cover as many as we can. Those that we don't get to today, we'll be sure to follow up with you guys. So let's just dive right in. The first question I have here, Release 16 devices are yet to hit the market in a big way. However, 3GPP is already working on 17 and 18. Isn't it too early?
So let's,
take that.
I'll start with that, Safi, and then it's like I was just saying towards the end of my presentation that Release 16 chipsets have really just come into the development cycle here in the first part of 2022. And so if you think about that 18-month timeline, most of the module OEMs will be starting to do their certification processes with the regulatory bodies and the carriers towards the end of this year and into the first of next year. And then the end customers will have to go through that process with their end products. There'll be some parallel development as we go through the rest of this year, but you're looking at Q1 of 2023 before you see any commercial products. Is it too early to be thinking about Release 17? No, because staying on top of what the carriers are going to support from these feature lists and the timelines, it's very important that we hear from the marketplace what everyone's looking for, so that as we're doing development, we're taking into consideration all the different use cases that are being thought of out there. And the sooner that stuff gets integrated into the chipset design and or our module design, then ultimately the end product, the better for the industry and the results. Safi, you got anything you want to add?
Just real quick, I think you pretty much answered it. I just wanted to say that coming from an engineering background, I can just appreciate, all the effort that engineers have to put in to perfect and simulate and make proof of concept of all the new features before it makes it into the standard. So it takes time and effort to build up a new feature, and that's why it's not too early, because you think of an idea, you try it, and then you build some proof of concept in an internal lab. And if it works, then you go and propose it, and then people debate on it. So there's a whole process, and that takes time. So that's why.
Great. Thanks, guys. Next question we have, should operators wait for RedCap and not invest in NB-IoT, LTE-M, Cat1, and other IoT technologies now?
Go ahead, Safi.
Yes, that is a very good question. So there is a very clear distinction which may not be very clear to many people, and that is that the RedCap definition is not for NB-IoT and Cat-M devices. So NB-IoT and Cat-M devices are already 5G ready technologies, and they are compatible with 5G, so they can actually be available and used on a 5G network today and in the future. Now, RedCap is a Cat1 and Cat4 category device replacement technology. So the Cat-M and NB-IoT are considered narrowband technologies for sensors and low power and low data rate devices, and for long battery life or meters, smart meters, and tracking devices and things like that. They will operate with a 5G network in a method which is basically called NSA, or non-standalone, where the LTE core network will be able to serve the Cat-M and NB-IoT devices, and then the 5G network will operate seamlessly with the devices where they could exist for a long time. RedCap, on the other hand, is going to eventually replace the Cat 1 and Cat 4 devices, and those are LTE-based devices today, and whenever that commercializes tomorrow, then they will have a 5G native Cat 1, Cat 4 device.
Great, thanks, Safi. Next question we have gotten. When 5G was first released, so release 15, price points were substantially higher than LTE. Do you see this changing with release 16 and 17?
I'll take that, Amanda. Yeah, the initial 5G chipsets and the development around that being first time through was definitely a significant increase in the price points in the marketplace. With release 16, there's going to be, like we've seen in previous technology life cycles, there will be cost down efforts, and we do expect release 16 products to be substantially lower than the current 5G modules that are out there today. It's still going to be higher than LTE, and part of that is because the transition from LTE to 5G won't start for probably several more years. But as Safi was pointing out with RedCap, you also have your Cat 6, Cat 9, Cat 11, Cat 12, and Cat 18 products that are in the market today. And all of those are going to have to move to 5G. So at some point, you'll see the two markets kind of blur the lines. And a lot of that has to do with how much adoption there is with release 16 versus 15. And a lot has to do with the fact that, Qualcomm is going to start having different chipsets to hit different parts of the market, where the very first version was kind of one size fits all. And so for some markets, it was priced beyond reality. And in other cases, it fit the bill. So yeah, we definitely see that over the next 2 to 3 years continuing to move down towards the LTE price points. And eventually you'll see 5G kind of swap over and you'll see 4G go away. But that's going to be another 5, 7, 10 year time cycle. And we can talk about very specific cases with anybody that's interested.
Thanks, Jeff. It looks like we are just on the hour, so I believe that's all the time we've got for today. Audience, please be sure to check your inboxes in the coming days for the replay link and a few other resources. Jeff, Safi, I want to thank you for your time today. Some great information, and thank you to everybody who joined us.
Thank you, Amanda.
Thank you.